Hey there, welcome back to the Andromedoom devlogs, episode number 9. If you'd like to skip ahead to the content, please check the timestamps in the description below. Now in today's tutorial episode, I'll be showing you how to change levels using two simple techniques. One just using simple signals and the change scene function, and the other way using Godot's built-in dictionary that checks to see if a level has been unlocked and then instances the packed scene. And in today's devlog for the Andromedoom main project, I'll be showing you the progress on the alien AIs. So far I've coded the first three, the crab, the octopus and the squid, and the projectile system as well, with some changes to the camera. Let's head over to the screen. So this is where we left off last time. So far we've got one level, which I've called Sydney. We've got the player pad movement, an alien that turns and rotates after a given while, and eventually wants to land. We've got camera shake and player fire. There we go. Now I've extracted this entire scene away from the level manager top node and just called it Sydney, and I've made a copy to simulate the next level, which is Tokyo. And I've just removed the alien and the building from this one just to distinguish between them. So first let's create a new scene, inheriting from user interface. And here I'm just going to put in a title. Put the title underneath its own control node. So we can adjust the layout. So that's in the center. And here we'll add a button. And we'll press start for the text. There we go, add a button, create the start text, scroll down to theme, underneath control. You can update the default fonts by loading your font file into here and adjusting these parameters. Let's call this start menu. So here we'll attach a script in C#. Go to your button resource, go to node, button up, click connect, start menu, on, start, button. So we got to create this method. So we use the ChangeSceneTo method. And what we do is we pass it an instance of a packed scene. So what we can do is go here, packed scene, call it starting level. And here we can say starting level. And if we hit build, so we can see the empty field here where we pass in a level. Now we don't want to pass this in directly. What we want to do is pass in the level manager scene. So let's take level manager, put it in here. So let's test this. There we go. Our level is loaded. So now instead of going into the gameplay level directly, what if we wanted to create a map selection screen? Let's do that next. Now underneath level manager, let's remove by default the Sydney level. So we'll just delete this node. Let's go into our level manager script. And here, let's create a new Godot dictionary. And we'll export it as well. Before we can do that, make sure you use the Godot.collections namespace, and we'll call this levels. Let's build this. So now we have a Godot dictionary here. What we can do is pass in keys and values. Let's make our keys strings. So the first level would be Sydney. Now what do we pass in here? Well, we could make it of the type object, where you can drag it in here, and then when you call it from script, you can instantiate it. However, we also want to keep track of what levels have been unlocked and which ones have not been unlocked. So instead of making this an object, let's make this a secondary dictionary. And in this dictionary, we'll add another key. this one scene, and we'll pass the Sydney scene in there. First we'll make this an object, then we'll pass the Sydney scene in there, and we'll add another one. We'll say unlocked. Here we'll use a bool, and we'll say it's unlocked by default, and we'll add that pair. Nice. Let's add another one for Tokyo. By default, we'll say Tokyo is locked, and we'll add that value there. And make sure to add the Tokyo key value pair. There we go. We've got Sydney, we've got Tokyo, both of them are dictionaries with additional information about the level. Okay, now we want a map selection screen. So what we can do is make that as another level in its own right, its own packed scene that is loaded by default. So let's create that first. Let's add another user interface. We'll call this scene map select. So let's put in a sprite here. And we'll also add a text label. And when using text, it's best to use BB code so you can format it. And here we're just going to say level name. So we pass in the main theme, the theme we created earlier for the button. And let's call this, let's change this type. This is actually a button. We won't put in any text, but we'll give it an icon. There we go. And you can use a theme here to get rid of the gray background, but we'll let that go for now. So we'll call this, let's call this Sydney, and we'll attach a script to this. We'll call this level button. And we'll export a string for level name. And we'll default it to level name. And when it's ready, we'll get its first child, because there's only ever going to be one child, which is that rich text button, rich text label. So we'll call it label, get the first child as rich text label, and we'll say label dot bb code text is equal to the level name. So let's build this. Here we'll set it to Sydney. Save the scene. Let's run this scene just to see that the level name has been updated. Cool. And similarly, we can duplicate this, call this Tokyo, and we'll move this somewhere here. There we go. Now, let's call this map selection. And on our level manager, let's add another key value pair called map select. And here, again, we'll add another dictionary. Set the scene to map select. Set it to be unlocked by default. Add that. and we'll add that. So we've got 3 levels there. So on our level manager script, which I have unfortunately called object pools, but I'll leave it for now. First, let's create a function called update level. And this will take a string parameter called level. First thing it does is it clears the level. So let's loop through just in case. Now there shouldn't be any more than one direct child node underneath the level manager, but just in case, we'll clear up everything. So for each get children, so this returns an array of references to the node's children, and we can iterate over those. And we can just say child.q3. Then we can say add child. But what are we adding? Well, it needs to be a node instance. And the node we're instancing is a packed scene from the dictionary. So first we need to create a new variable node called instance. We'll go to the levels dictionary. We pass in the level string. So that gets us to the secondary dictionary, which contains the scene and if it's unlocked or not. So it's good practice to check to see if the level is unlocked first. So we say if levels level unlocked. So unfortunately we're left with this vague syntax here. We have to cast the first one to a dictionary, because this means that in this dictionary, every key refers to another dictionary. So now in this secondary dictionary, we take the unlocked key and we cast it to a bool. And then we say if it's not unlocked. And if it's not unlocked, just return. However, if it is unlocked, take this, take the scene, cast this to a packed scene, and we'll instance the packed scene. Now this syntax is very messy, and in my prototype, the way I actually built it was just pass a string and use that to refer to a resource path. So I might take the level name and say pass a string resources scene slash levels slash plus the scene name, and then again .tscn. So if this is a bit too much, then either break it down or maybe take a helper function that can convert this Godot dictionary to a C# dictionary, which is aware of what type is under each key value pair. Unfortunately, I don't think exporting a C# dictionary to the Godot editor works. So you'd have to create some kind of auxiliary function that converts a Godot dictionary to a C# dictionary. And if you know a workaround, please let me know. So now we've got our node, we just add child of instance, and this adds it underneath the level manager. There you go. So just clear the existing level if it's there, check if the requested level passed as a string is unlocked, then instantiate the packed scene of that level and add it as a child underneath the level manager. And so when we call the ready function, we want to update the level to map select. So that will be the first level on load. Alright, fingers crossed, let's test this. There we go, we're in the map selection screen. So the next step is getting these buttons. So our map level buttons live on the map select scene. And this map select scene gets loaded under level manager. So it's a two-step hierarchy. So if we go back to our level button, so let's get the level manager script, and I'll rename this from object pools. And on the ready function, Now, if your project gets more complex, you may want to avoid this somehow. Figuring out a way to go down the tree instead of up the tree, that's good practice, but we'll leave this as it is for now. And here, we're going to connect a signal. Now the name of the signal is already on the button. So each button has a signal called button up. So we'll use that name. And the target is the level manager. And the method that we're connecting you to, it's the level manager dot update. Let's make this public. Update level. And now, when the button is pressed, we'll emit the signal being pressed. And the parameters that we're sending is the name of the level. So when the button is pressed, it emits a signal of pressed with the level name attached to this button. It goes to the level manager's update level function. So the level manager takes that string and passes it in here. There you go. Alright, thank you for watching. Hope you took something away from that. I don't like building UI. The visuals and the logic, it does get a bit complicated. So if you have any suggestions, please put them in the comments below. I'm really looking forward to improving how I handle scene changing. And if you're enjoying the series, please make sure to hit like and subscribe, and stay tuned for the devlog if you're keen for that. That's coming up. Alright, welcome to the devlog. Where we left off last time, I just had the alien crab bouncing around the scene, not animated or anything like that. And when I press the spacebar, the screen shakes and I take some damage to demonstrate the grayscale shader. In that time, I will show you the progress I've made. So a few things. The camera now tracks the player. So there was a bit of code refactoring there. Made the buildings destructible. And now you can see that the aliens themselves are animated as well. And so this just involves reading them in simple skeletons in Blender. Oh, I just got inked by the squid. And exporting them using the non-linear animation editor. There's a link by the Savvy Barbarian, I think it is. I'll put it in the description below. That helped a lot. And I might create my own video as well if you're keen for that. But basically use the non-linear animation editor to export a bunch of different tracks. So just the basic engine, the landing animation, and the firing animations are the main ones. And if you look real closely, you can see that the players themselves, the player ship is also animated. When firing, when idling, it vibrates like an engine. And when moving, the tank treads squeeze back and forth. So very simple animation, but hopefully it adds a bit more juice to the game. And if the camera's shaking, it's because the aliens are, you know, attacking the buildings. So I've also implemented something called the armour system. As you see, if the higher an entity's armour, the more likely a projectile will bounce off. So that just adds a new dimension to the gameplay, to what makes a ship good or what makes an alien challenging. So here you might see the landing animation for the octopus. There we go, it pulls its tentacles up. The crab is still going strong. I've also updated the turning AI to be a bit more sophisticated. Instead of rotating in random directions, once it collides with an object, it will bounce off using the built-in bounce method. It can be a bit unexpected at times because you're working with cylinders and round objects. And see, as you can see there, the crab stops, fires one from each pincer and continues moving forward. Conversely, the octopus and the squid fire. Oh, the octopus stops and fires, but it turns while it's moving, and the squid also turns while it's moving, but fires while it's moving. And I'll show you the ink shader one more time. So the squid dropped it over the building. The ink does no damage. There we go. So ink splatters the screen, reduces in opacity, and moves down the screen, just like Super Mario. I've also implemented a simple projectile, simple particle system to simulate explosions. Needs a bit of improvement on the visuals. So the next steps for me are a bit of code refactoring, because between the squid, the octopus, and the crab, I just copy and pasted the code. I've encountered a few issues with Godot where if you use partial classes, the editor crashes, so I can't use partial classes. I'll have to look at a way to sort of update the state and the state machine in such a way that I can make inheritance work. Because at the moment in the ready function, I am initiating all the states, so I should probably introduce a new function. The octopus can inherit from crab instead of alien, and then all of the similar behavior gets abstracted away. So because the crab, the squid, and the octopus behave almost the same, they can share a lot of the common function, and then just update the state machine states that are specific to that alien. So I'll work on that next. Code all the alien AIs. So there's another 5 aliens to go: the shrimp, the goblin shark, the stingray, the man-o-war, and Leviathan, the boss. Once all those are done, I'll work on the invasion meter, which I imagine would be quite simple, which tracks the number of aliens landing on the level, and if too many aliens land, the level is over. Then I'll build the weapon system, where you tap the colored dots to load new weapons onto your ship, and fire those instead of the standard cannon. And after that, I'll take a look at the dynamic mesh damage, particularly to the buildings, so that there's a visual indicator when the buildings are damaged. Thank you for watching, hope you enjoyed that. If you're enjoying this series, please make sure to hit like and subscribe. Leave any comments, questions, suggestions in that little box down below. I'll see you in the next episode, the final in this 10-part series, before I start releasing the videos and getting your feedback. I'll be showing you how to code the final boss, Leviathan, which behaves like the Eater of Worlds from Terraria. So hopefully should be a fun one. Thanks for watching, guys. I'll see you there.